5, 4, 3, 2, 1, 0.
This is The Big Picture, an official television report of the United States Army, produced for the armed forces and the American people.
The United States Army, as almost everyone knows, is placing an ever-increasing emphasis on guided missiles, projectiles which can deliver deadly conventional or atomic warheads to enemy targets hundreds or even thousands of miles away.
And Uncle Sam needs you to help him load his rockets. But before we can do that, I'm going to show you how I restored this game. I'm showing you just one of the corners. The others are in similar shape, but this is the worst one. We have this plywood peeling off, and when you come down here to the dovetail cabinet, it's splitting open and going way far back. That's about 8 inches back. So underneath there it all has to be glued and then resecured, and there's a lot of filler that's going to have to be added here, and in here all of this has to be reattached. As you obviously note, the car is completely missing, gone, and right up there is where the car would plug into, and there's a slip ring assembly here where all of the electrical signals are allowed to come down through that metal cable, so that if the car completely spins in a circle, you're not twisting up the cable, but it free wheels in here. And it's missing the legs, so we'll need to buy a set of legs for it. And then when I pull out on the handle, it goes in the opposite direction. And once again, that's a right-hand turn, and that's a left-hand turn. This top channel lifts off so you can get to the back glass. And we're going to pull the glass out so you can get a little better look at it. And there's quite a bit missing around the 100 score. That'll have to be filled in Photoshop. And if we look at the back, you can see what parts are opaque, and where the white is, that is what has to remain translucent, semi-opaque, where the light can come through. Your weather stripping is gone on this side, so that all needs to be replaced. I will save that decal and just do some touch-up paint there, but leave that and that since it's original.
I should like to report to you on the Army's great progress in the field of rockets and missiles, and show you the results of the teamwork effected between the Army and great names in industry in producing these modern weapons of warfare.
I'm going to start re-gluing the cabinet, but with as much wood as missing and how bad in shape it's in.
My advice to you is to start drinking heavily.
Gluing and clamping has begun. I removed the oak trim, gotta sand it down and refinish it. Now I'm making up stencils for every color, 4 colors on this cabinet, and this is the red stencil. And every place there's going to be red on the cabinet before I sand it completely down. Cabinet completely stripped down now that I've made the stencils. Yellow is on, now I'm starting the turquoise. There you go. Here I've masked off the stripe that belongs on the cabinet. So did a little freehand curving, and I am ready to paint the stripe. I'm using a drafter's dry cleaning pad on this backdrop, and here's what the backdrop originally looked like, and you can see there's where I've cleaned it. So that's working out real well. I'm going to clean up the rest of this, and there'll be a few spots that can't be repaired, like this hole here and up here, but the thing is in such great shape and the colors are so bright and pop that we got to leave it original, just clean it up some. The front rail has been reattached by using screws instead of nails, so it will hold it good and sturdy. And also I used the original nail holes, but then in between each nail hole I put in another screw, so there's twice as many holding this rail in place. I was able to come up with this much of a car, original car, but there are gears missing, both the motors are missing, so there's going to be a lot of reconstruction work here. Try to figure out how I redesign that and build it. I'm modifying this truck die-cast metal, and with this piece removed it can now fit down on the chassis, and I have room open here for the steering mechanism. This is my first attempt at coming up with a steering motor mechanism. So I've rebuilt all these gears and put a new slip disc in there. Had to make one of those, it was missing. Put a spring in here, and got this worm gear, made this coupling shaft, and got these motors, made this bracket, mounted it all. But I'm not happy with the way it's working, because when I apply electricity to it, alright, the wheels turn very quickly. The steering goes from left to right, from right to left, pretty quick. But I want this to go slower, have my steering turn just a little bit slower when you turn the wheel in the front of the cabinet, have more control over it. So I'm going to swap this motor out with another one that's got a gearbox on it. And here's the planetary gear system that is the speed reducer. Got an internal gear and then actually 3 separate stages of planetary gear reduction. These are some of the gears laying out. So when I get this all back together, I'll show you what it looks like. Here's the stack up. You can see the 3 planetary gears, and then there's a whole nother set of 3 in this sandwich, and then this outer drive output here drives 3 more planetary gears, and all of that is going to go down inside there. And here's the last set of 3 with the output drive shaft. So here's the reassembly of attempt number 2 with the planetary gear system in there and the motor that goes up to a higher voltage. But when I apply voltage to it, that's turning way too slow. It'll take forever for the wheels to turn on that. So back to the drawing board. The truck is coming along. I'm continuing to hog out metal so that the gearbox and motors will fit inside. And then also I've started on a canopy, which is right here, truck canopy. Took some metal and bent it up, sealed the ends with some JB weld, and I'm now going to paint it a army green. I had taken some dimensions beforehand and laid it out, so this is what it looked like on flat metal before I started bending it up. Those were all the cuts and folds I had to do. The truck body's coming along. I fashioned a rear bumper and put some danger decals on there just like the original had. Got a few more decals to put on it, make it look like an army truck. And right now I am working on the front bumper, and it has to be magnetized, so I've got a magnet in here, and I had bought all of these magnets, different shapes, sizes, different strengths, so I could experiment and find the one that works. Those work. But what we have here is one magnet. It's all it takes. Grabs onto that, and now I can move it around the playfield, and it holds on to it. I'm starting to build the bracket that will hold the front of the car down and also allow the cable to come in through the top of the roof, bring the electrical wires. And I'm staying true to the period of the game. Every time I have to put something in or fashion something new, it's being put in with slotted head screws, not Phillips.
Like it or not, we were in the space age, and I was very much interested in this country's missiles and what they could do for our defense above all things.
The throttle has a spring-loaded pin that makes contact as you slide back and forth. And a trick that I've learned over the years in this particular setup, they expected the electricity to flow through this and to the surrounding metal, which this all had good continuity when it was brand new, but as the years goes by and it gets oxidation and corrosion, tarnishing on it, you no longer have good connection here. Where you see the wire, the power coming in goes to the cylinder around where this pin comes up through, and was just making contact that way. And so what I've done is, from where that wire comes up, I've soldered a flexible connection right to the pin, so now electricity comes up and goes straight to the pin, doesn't have to rely on this mechanical connection and how that gets tarnished over time. So this will be a good strong connection now. These two relays see a lot of pulsing, a lot of vibration, so they mounted them on a sheet of rubber, and this is new rubber because the old one was pretty much falling apart. So there's not much left of it. It's not very pliable anymore. I replaced the capacitors on here. The old ones were reading over 1 microfarad, and they're supposed to be 0.22 microfarads, so they're nice new ones. And this plywood is bowed pretty badly, probably a good 1/2 inch bow right in the center. And so what that would do is cause this part to be up higher, and then the shafts that come through here for the throttle and for the steering would not line up. There'd be binding because this is a 1/2 inch higher. So I added this strip of wood here, and it's glued and screwed to the bottom of the cabinet, but I'll be able to put screws in and pull that plywood down so it's nice and straight again. It's looking good, Mom.
But you got the yellow up on the thing here. You want that little crack covered too?
Yes, please.
Okay.
This is the timing motor that times the game. Gives you 2 minutes of play. And I opened it up just to inspect, make sure that everything looked good. And surprisingly, the grease in here is still good and soft and liquid. It's not all caked up and hardened. So this motor's in real good shape, and we'll go back together now. And we'll test it now that it's back together. make sure it's running smooth. I had 3 of these socket connectors that one of the tabs had broken off. You can see that there's a tab on this side but not on this, tab on this side but not on this. They get old and brittle and they crack, and then the tab falls off, and then you'd have a poor connection when you put the pin in. It's only being pressed on one side. So I had some extra of those and I've replaced them. You see the fresh solder there. So now I've got both tabs in there and they've been cleaned and make a nice good connection when I push the pin in. Alright, going to work on this disc and wiper assembly next. You can see this is pretty rough. It's got rat urine on it, corrosion, so this all needs to be cleaned up.
Only after this process can the punched cards be fed to mammoth scientific computers, which can be set to work to produce the statistical results awaited by missile scientists and engineers.
The wiper disc has now been cleaned up, and all the pieces on the back side of this assembly shafts are clean. Plungers from solenoids cleaned up and ready to put it back together. There's the wiper, contacts good and clean. It's all back together now, cleaned up, and got to check its operation. So when you have this plunger pull in, it steps up one rotation at a time, one indentation at a time, and then this is the reset solenoid. When it pulls in, goes all the way back and it needs to line up here in the home position. So the very last thing that I'll do is put a very, very thin coating of this special purpose conductive grease on these contacts. Very, very thin, but it helps the armature move, prevents binding, and helps the electrical connectivity of the wiper discs. There is a hole the tip of the spatula is pointing at in this collar, and that hole allows you to put a drop of oil in there to lubricate the shaft of this wiper. No major issues with this relay bank, so I just cleaned it up. Cleaned and adjusted all the contacts, and it's ready to go back on its mount. Both this wiper disc assembly and the relay bank assembly are held onto their mounts by these little clips, and there was a couple missing, so I added them. And then on this relay bank there is an eccentric screw that goes through here, can be tightened, and as you turn this it would move the position of this outside diameter, and it would go in or out and push this either further in or let it come out, because this is what stops it. This arm rests against this. So you need to adjust this so that when these relays energize and the armature comes back, you want just barely a tiny gap here. You don't want to have this adjusted all the way around, pushing this too far forward, which would be pushing on this, and that would not let the contacts close all the way. So this sliding arm needs to come all the way down so that the contacts are able to properly open and close. Then when you energize this solenoid, that will pull in and reset all of those. On this motor and cam switch assembly, I take them apart because these motors always need oil in a couple places. This right here has got a wick or cotton in it that soaks up oil, and so I lubricate that really well, get that full of oil. And that's a bronze bushing. It's what's called an oil light bushing, has oil impregnated into it, but after all these years, how old it is, I always put a drop in there. Then you have similar on the back side, the same cup that has to be, or the same reservoir that has to be oiled, and then any pivot points get oiled. So like that one right there, and any other turning gears, just a drop of oil there to keep everything lubricated well. Next to come apart was the 1 to 5 count unit. Had to clean those contacts and clean up this wiper. There's the one pin that makes connection with all of these contacts, and on the back side we have the wire soldered so we have good electrical continuity. All the light sockets get cleaned out. Get all the tarnish and corrosion out of there. Then we remove any debris. And I finish this up with some solder wick across the back side to make sure I have a really good strong electrical connection. You see I haven't done these yet, so that's what it looks like before and then after. Here's all the old bulbs. A lot of them still worked, but corrosion and the blackness, I'm just going through and replacing them all. So everything's getting brand new bulbs in it. The play counter was frozen, so it's been taken apart and cleaned up.
A most extraordinary area, utilizing highly complicated electronic equipment, is the Flight Simulation Lab. Computers, carefully set for a particular missile problem, will provide the answers on a plotting board.
Working nice and smooth. And this will be set to 0 when you get it, so you'll know how many plays you put on it, because it'll be right at 0 plays, all restored. Now I'm taking the underside of the playfield, the driving area, completely apart. And these are the rollover contacts. Car rolls over to get points when lit up. So if I remove the little C-clip, the button comes out, and that's what they look like before and after. Every single piece has got to be checked. To give you an example, where the solenoid plunger pulls in, there's an arm that pivots here on this pin, and the pin is loose. So that would make things not work properly. Got to tighten up that pin. Now that is a nice tight fit.
That's what she said.
Bottom side of the playfield is cleaned up, put back together. Got all of the pins on the contacts cleaned up, all the corrosion's gone. And there's that pivot that I had to tighten up. So when this solenoid energizes and pulls in, that moves this rod, and that's what ejects the 5 pucks back out onto the playfield. Top side is going back together, and when I pull in on the solenoid by hand with my left hand, you're looking at the back side of the playfield, or from the rear view, you can see that this rod coming through here is what pulls in and causes all the pucks to eject at one time. With a little bit more of the playfield back together, you can see that when a puck is pushed into a number, this spring-loaded finger here, or spring finger, grabs it, and that's going to hold on to it so the truck with its magnetic front bumper doesn't pull it back away. So that will hold on to it, register the point, and then when it's time to kick it back out, the steering assembly is back together. And what we have here, this particular set of switches, is what's called double pole, double throw. And that means that there's two different sets of contacts, and when I turn this wheel in one direction, I go up and I close the two individual poles. I close it in one direction, and then when I go the other way, those two poles go down and hit a second set of contacts. So what we have is DC voltage coming through here and going on to the motor. And when I move this either up or down, that reverses the polarity of the voltage coming in and going out to the motor. So I turn the wheel one way or turn it the other. And then every time this closes, this set of contacts here, that's what actually completes the circuit and lets it go on. So you actually have pulsating voltage to the steering wheel for either turning the wheel left, the front wheels left, or turning the front wheels to the right. A view from the other side so you can see that DP-DT, double pole, double throw contacts, either going down or going up. I cut a new set of leather discs. There's two discs in here made out of leather, or two washers, and that's what causes the slip ring effect, so that I can keep turning this wheel around and around and not hit a stop. And this is spring-loaded to press the disc together to actuate that arm. But as it says here, if it ever is not running smoothly or if it's jerking, you need to put some neat's foot oil. So these discs have been thoroughly lubricated with neat's foot oil. Should last just several years. Here's the old leather discs, and as you can see, not real leathery anymore. Pretty brittle and hard. We have a similar set of DP-DT switches here for the throttle, forward and reverse. And so the proper adjustment is when these contacts are all open, none of the 6 contacts are touching each other. Then down here, this contact should be right in this open space, right there, so that all of this is applying various or varying degrees more and more voltage to go forward, and then on this side it's an increasing set of voltages for going reverse. This is a close-up of the forward and reverse contact set DP-DT, and it's 5 contacts, not 6, like I said before. But what is very important, I've put cardboard here behind it so that you can see through and get a good look at the contacts. It is very important that these contacts be set up in what's called a break before make configuration. What that means is I've got voltage coming in on one center contact of one pole and ground coming in on the center contact of the other pole. And when I push one way, I put that positive voltage and ground out to 2 contacts, one on each pole. And when I pull back and go in the opposite direction to go reverse, what happens is positive voltage and ground are delivered to another set of contacts, but when they come off here, the way they're wired across here, it's the outsides are wired together and the inside is one common one. So what this ends up doing is being the polarity reversing mechanism for supplying voltage to the motor. And when I say it has to be break before make, when I'm here in this center position, I can't have both of the contacts of one pole be touching at the same time. In other words, if these were a little bit closer together and I actually had all three of these touching before it came all the way here and opened this, that would actually short out the power supply. Wouldn't be a good thing. So you need to make sure this is properly set up when you're at the neutral position, that you have all contacts open, and that when you go one way or the other, that you always break the contacts of the pole before you make the other side of that same pole. You have this large resistor that's in series with the motor, and it's tapped off different amounts of resistances going to the different pins here. So what happens is, as you move this forwards and backwards, you're putting more and more resistance, or less and less, into the circuit, supplying either more or less voltage onto the motor. So that's what makes it turn at different speeds. To return a stuck coin, you twist this knob, and if you have to remove the slug rejector, as you put it back in place and go to snap it backwards, you want to make sure that this lever is not down and not up, but that, see, there's two fingers on here, upper and lower. You want this to go in between the two, like that, so that this bar is captured in the finger, and that's what keeps it in the right position when you operate it. The coin box was missing, so I went ahead and made this tray. Alright, I'm going to take you through just a few of the basic operating principles of what's going on inside this mechanism. You have a selenium rectifier, which is turning AC into DC, putting out about 20 volts DC, and that's what runs the steering and also the throttle. And through these mechanisms I've shown you earlier, that allows it to be reversed polarity. This unit here keeps track of how many points that you have for the 5 different rocket locations. So in other words, when I hit rocket number 1, this will step up 1 time. Rocket number 2 causes this to increment 2 times. Rocket 3, 4, and 5 increment 3, 4, and 5 times. And so once you get all 5 rockets loaded, then this will be fully sequenced all the way through its numbers. But the actual score that you're getting in hundreds and thousands of points, that's kept track on this disc here. You've got a bell that rings for your points, and so once you fully load the rockets and you run over one of the trip contacts on the playfield, then this will reset to 0 as your 5 pucks get kicked back out onto the playfield. This is the main timer motor, which is causing the game to run or stop in the game over mode. Right now this contact right here is open, and so once you start up the game and this tab of the cam rolls off of it, that'll keep the game running for 1 full revolution. And on this side you have contacts that close to cycle this motor here, and so this is doing a lot of the resetting of different things. For example, and we have a 0 position. This is the at rest with the tab of the cam here, but when it's rotating around, it resets different things that are going on in the machine. Like one of them resets this bank of switches, another one will reset or energize this solenoid, which, pulling this in, is what kicks out all of the pucks or the rocket payloads back onto the playfield. So all that's being controlled here. And let's start a game and watch what happens. So I will hit the button. We are reset, and so if I go through, now this is spinning and it'll make 1 revolution. If I hit any of the playfield contacts, I get 100 points. This stepped up once. I get the bell ring, and what I'm going to do now is load the payload into rocket number 1. You'll see this step up 1 time, and this will step up 1 time. Alright, Right? But rocket number 2 will cause this to advance twice, step up 200 points here. And then the third rocket is 3 pulses. The fourth rocket is 4 pulses. And then the fifth rocket is 5 pulses. Alright, and the fifth rocket will also cause this to cycle to reset all of your playfield lights. If you had rolled over any of the lights were out, they'd all be back on again. Because now you're fully indexed here, and any of the playfield lights you roll over will cause that to move. So that was done automatically. It resets all the lights for you right here halfway through the game. But now that I've gone through all of the rockets, hitting any one of these rollover switches, alright, we'll hit the pucks, eject the pucks back out, cycle this, reset everything, and now we can load more rockets. So now that's set to go. Any playfield rollover will energize this and kick the pucks back out. And you can just keep doing that and keep gaining your score. Alright, so now we're just about there. The cam made it to the end. It opened up this contact, game over lights on, and no additional power scoring or anything's going to happen. Alright, here's a little bit of a closer view for you. And so again, you'll see this step up 15 different increments to keep track of 1, 2, 3, 4, and 5 rockets. And then this bank of contacts along here are for each of the playfield rollover buttons. So as I hit each rollover on the playfield, you'll see a different one of these solenoids trip. Let's start a game. Everything gets reset, and now as I hit rocket number 1, you'll see this step up and I get 100 points here. Alright, and now we'll go rocket 2, rocket 3, 4, and 5. And then this cycles to reset any rollovers that may have been hit, but I didn't hit any with my hands. Now I will hit one and it'll cause this to eject the pucks back out. So I'll trip this one right here. Okay, reset, go on for more rocket loading. But notice when I hit this one, I had the corresponding contacts get triggered, and so all of these contacts will trigger with each of the playfield rollovers. So I'll hit another one, trip that one, that one, and so now they're all tripped. And if I start loading rockets again, now we're up to the halfway spot on the time, so that causes this to spin and reset everything. Just in case you had all the rollovers out, you would be able to get them back and have more rollovers now lit up. Alright, but I'm going to load the rockets again. And then eject them out onto the playfield. This is the slip ring assembly that's all put back together, and I managed to find a cable that is almost exactly the same as the original. And so when the car, that hooks to here, when the car turns, it needs to turn this set of slip rings around in a circle, and electricity is transferred from these 4 stationary rods or contact wipers to the rotating discs. And there's a second set of fingers on this back side. So you've got, for each of the 4 signals, there are 2 points of contact, one on the front, one on the back, to make sure you get good electrical continuity going through there. backglass is being reproduced. See, it had a lot of flaking there and missing paint. One thing I didn't like about how this game illuminated was that the fluorescent lamp that goes right up here to light up the whole playfield, it also would shine light directly backwards onto the back glass, and it was washing out the colors, washing out the illuminated sections a little bit. So what I did was built this cardboard strip so that when the light's in there, it kind of protects the light from going and shining right onto the back glass. So I think it helps make that pop a little bit more, illuminate a little nicer. So with the fluorescent bulb in place, it lights up the playfield nice, but I'm keeping a little bit of light off of that back glass. These are the original tires, and as you can see, they are hard and cracking open. Two of them fell apart on me, but that's just about ready to crumble. So these tires were not really usable. So what I did was I made molds, and I'm casting new tires. So this is a brand new tire. You can see it's nice and flexible, and the back side looks a little rough, but that's where my flashing is, or where the outside of the mold is, but that goes on the inside of the tire. You'll never see it. This is the side you see, and it's a nice quality reproduction, nice and flexible. I will have these tires for sale on my website. They go with both a Genco's Motorama and the Space Age, same car. The price is not going to be cheap, I'm sorry about that, but I had to buy this vacuum chamber. I had to do a lot of experimenting to find just the right way to make molds, a lot of trial and error and lessons learned, and find just the right durometer rubber. So the price on my website is going to reflect the time it takes to do this. Plus, every set is hand poured. This isn't a mass production situation. And then when they come out of the molds, here's some that have been poured, they're curing. When these tires come out, then they have to be baked at 150 degrees for another 4 hours. They take about 16 hours to cure. So there's just a lot of hand labor involved in making a set. But if you do need them, you'll have a nice new set of tires for your Motorama or Space Age. Alright, I've got to make one more little adapter arbor for the gears. Checking the fit on this hole for the motor shaft. I want it to be really snug, which it is. It goes on there good, but it's really snug so that there's going to be no wobble at all in the worm gear. Alright, I'm going to measure this shaft to make sure it's at the right dimension before I cut it off. And now normally I wouldn't do it this way where I turn this shaft here on the inside. I would flip this around and I would be turning this shaft, or this smaller diameter, on the outside. But this is an old tired lathe that's got some slop in the babbitts of the headstock, and so by me drilling the hole and then also turning this diameter at the same exact time without taking it out of the chuck, what I'm doing is guaranteeing that this hole and this OD here are exactly in line with each other. And I need that because the motor goes in here and the worm gear goes on here, and as it spins it needs to be perfectly in line and not have any run out in it. See how bad this thing jumps. Time to get a new lathe. But there you have it. And just a little cleanup on this face. Take off that little tip that was on there. And now we're ready to drill and tap the set screw. Now I'm putting the 440 thread in it for the set screw. And now repeat the process for the little adapter I made. There it is.
We take you now to Remco's Project Yankee Doodle Secret Rocket Test Center, where a giant Atlas rocket will blast a new satellite into orbit. The next voice you hear will be that of our project engineer.
Alright, you're about to witness what is the very first dry run of these new motors. And I think I'm going to go with these. So let's coin it up and give this thing a try. Pucks come out. Steering's good. That clicking is normal. You get just a little bit of movement each time you hear the click. And the instructions here, they tell you to load them in order to get the points, but you'll get the points regardless as soon as you load them all up. This is fun. Alright. Yeah, you got a whole bunch of points all at once right there. Alright, let me get this last one in. Go. Now get over a rollover and we'll eject it back out. Here we go, come on. There we go. So rollover ejects it and we get to go again. Goes. I think I'm going to adjust the speed a little bit. Yep. Oh, game over. Right, from that trial run, I wasn't happy with this speed control. It didn't have enough variation from slowest to highest. Pretty much all of these made the motor go almost full speed. It did speed up a tiny bit towards the end, but there wasn't enough variation from slow to fastest speed. So what I've done is I've set up this little experiment here, and this is the resistor that has taps in it that when you go in a different contact, you're putting a different amount of resistance in, as I've said before. So what I'm going to do is I'm going to experiment by putting in different amounts of resistance into these various taps, and we're going to make it so that there's more resistance on the low end slow speed, and then as you get up towards the high, there'll be just the resistance that's in this resistor there.
But still, she's got to make the trip to the launching site within a 10-mile-an-hour speed limit.
On the schematic, you have the drive motor, which is being fed power through that contact linear wiper arm. The throttle is hooked up to this, and it's picking off different contacts. And then this is that resistor with all the different taps on it. So what happens is you're picking off different amounts of resistance, more or less. So as you make the connection up through here and have the minimal amount of resistance, that's your fastest tire speed, fastest motor speed. And then right here you have going through and having the most amount of resistance, so that's the slow speed. So I'm going to experiment by putting some resistors in here, different values. And you notice that they give you an adjustment plug of what the top end speed would be, and I've already got it on the slowest, and it's still, I think, a little too fast. So there's that adjustment that they give you, and I've already got it on the slowest. So here we go. Let's experiment around. I'm going to start up a game by cheating. Okay, now that's making one full revolution, and if I bring the throttle in and out, okay, there's my fastest speed, but I've got this dialed in, putting an extra 40 ohms of resistance. That's 1 ohm per step, 10 ohms, hundreds of ohms, thousands of ohms. And so it's a decade box, or a variable resistor box, for doing this type of work. And then I'm monitoring the current, and there's an important reason why I want to do that. I'll explain in a minute. So as I go to the first indent, see, I am tapped in right here. This goes up to all of this, and so when I make the very first connection, either forwards or reverse, okay, so we're spinning a lot slower now, and I'm drawing 34 milliamps. Now the real test is when she's under load, meaning with the car here and actually running on the track. What does that 40 ohms do for us? So I'm going to take my throttle and just go into the first position. Okay, and that's about the speed we have there compared to full throttle. Okay. So I'm going to kick it up to 60 ohms. Let's see what that does for us. All right. So I think I like back around the 40 or 50 ohms. We're going to go with, I think, 50 ohms for that first resistor. Alright, it is also important that you consider the entire weight of the car, body and all, because that's going to affect the load on this motor. So I weighed the body, and I'm simulating that weight with this bolt and nut resting on it. And so now, with that in mind, start up again, and I've got this dialed in at 10 ohms. And when I go in the first indentation, okay, got that speed, so I can kick it up to 20 ohms. See, and that's quite a bit slower. So I'm going to go with that for the first index point, or first position on the throttle. However, under load, look at what the amp meter does. Okay, drawing over 100 milliamps when that car's running. So, alright, almost 150 milliamps. So I need to consider that when I figure out what resistor I'm going to use. Once I've determined that I want to use a 20 ohm resistor, that's only half the information I need to go buy that resistor. You also need to know the resistor's wattage. So that's why it was important that I was reading the current that I was drawing, because there is going to be 150 milliamps, that's the highest I read, going through that resistor. And if the resistor itself is 20 ohms, then we have to figure out the wattage of, or that's dissipated, how much power is dissipated in that 20 ohms with 150 milliamps going through it. And so Ohm's law says that voltage equals current times resistance, or you may see it written E as an Edward equals IR. The E stands for electromotive force, V is voltage, mean the same thing, just old school terms. E for electromotive force. Also, power in watts is equal to the current times voltage going through any single component. So using some substitution, if P is equal to IV and if V is equal to IR, then I can take IR and bring it down and replace V with it. So I have IIR, and that's rewritten as I squared R. So to figure out the power in watts, all I have to do is multiply the current by itself and then times the amount of resistance. So 150 milliamps times 20 ohms and 450 milliwatts, or just a little under 1/2 of a watt. So it's not going to take a very big resistor, but I'll put 1 watters in there, double the amount of power, ability to dissipate power at 1 watt, twice as much as I need, so that we should never have a problem. I've done the same thing with all of the connections to different tap offs, and so there's the finished product. And the wires here that used to be connected directly to the big resistor, they're now on this terminal block. I installed that and soldered the resistors in between them so it's good and sturdy, won't come off. And with the body and everything in place, full weight of the car, I've gone to the fastest terminal here now. If you needed to get a little faster even still, you could always move this green wire from here up 1. That would take out 5 ohms. Each tap is 5 ohms worth of resistance. And so we have a 4.7 ohm, a 10 ohm, and an 18 ohm. Those were the 3 I went with. And these are 2 watt resistors. They're just what I had, and that's a 1 watt. There are slotted head screws here and here, which will go in and out and cause these front steering wheels a tang, or a tab that's on the axle or the spindle goes and hits that, and so that's limiting the amount of turn. And when you go back the other way, this tab on this spindle will hit the others and limit your throw that way. So that's an adjustment you can make if it's turning too quickly or not quickly enough. And then there are 2 set screws right there and right there, and they come through and they press on this aluminum motor mount just in front of where it's mounted down. So by turning that set screw, you're putting pressure and you're flexing this just up a tiny bit. And what that'll do is adjust the amount of mesh between the worm and the driven gear. It is very important that you have just a tiniest bit of slop in there, or slack, but not very loose and not tight. Too tight will bind, you'll have bad performance or burn out the motors, and too sloppy and you'll wear out this gear. So same thing on this one. You want just the ever so slight, a couple thousandths of an inch of play is all you want, and that's the best you can do for adjusting these gears. This is the finished car that I reproduced. Tried to make it look like taillights, and got a little Felix the cat there taking explosives off to the rockets. U.S. Army decals. I saw that online on one of the original cars, so alright, the bumpers that I made. Army decal. I'm going to show you how to disassemble this if you ever have to work on the car or disconnect it completely for service. There are two slotted head screws right here in the back, and so I will take both of those out. One and two. And then there is a third screw right here on the roof. All three screws are the same. Made them so they're interchangeable. And then this body just lifts right off. And what you can do is go back about halfway up the cable, a third of the way up the cable, and just set the body down, and you have your two screws here. And then I attached these wires from the motors to the wire going up the cable with some wing nuts. So all you have to do is take these out, and then this cable comes through here and is clamped on by these hose clamps. And so if you get a pair of pliers, you can grab onto this, and the object is to squeeze it and lower it down. So you've got a bottom one there, you've got to lower that down first, and then squeeze this one, lower it down, and with both of these loose, letting go of this cable, then the cable will pull out and up. And with the wires disconnected, you just pull everything out, and you've got the car free to go do what you want with. To reassemble, just reverse the directions. Try to tuck these in here nice so they're not in anybody's way, not going to get close to the tires or close to any moving assembly. Try to make this as easy as you can to service it. So 3 screws and it's back together. Well, they say the third time's a charm, but in this case it's about the 10th time, because I went through about 10 motors before I found just the right one that I liked. So let's see those motors do their jobs. Here's steering and throttle. Here's a little closer shot. You can see that you only get a little burst of steering, but if you put the wheel, turn the wheel fast, it turns into kind of continuous with the pulsing. And throttle. I want to give a shout out to Todd McCulloch, former NBA player for the Philadelphia 76ers. Todd has a Motorama, and he had a spare chassis, just this bronze base with the steering mechanism and tires. If it wasn't for him, I would have had to spend a ton more work completely designing the car from scratch. But with just getting this base from him, then I was able to replicate the rest of the car and keep it pretty much as close to his original as possible. So because of Todd, not only did I save a lot of work, but he really helped my customer out in getting the most accurate reproduction possible. So Todd, excellent work. Thanks a lot. I'll be in your debt for many moons to come. Oh yeah, forgot about these. Make that the 13th time's a charm. I've added these metal strips in here. The original game didn't have it, but that helps clean up this cardboard edge, makes it look a little nicer, and also protects the cardboard when you have to raise the playfield so it doesn't scrape it all up. This is the original nameplate for the throttle, and you can see that it's pretty severely pitted. The customer opted not to do any chrome plating on this machine. There was really nothing I could do with this, so I made this. And there you have it. The other thing to watch for on your game is that when these get old, they also get stiff, and the tire will tend to slide on the playfield. It won't grab because it's not nice and soft, pliable rubber. So if you find that your car is sliding or the wheels slip on the playfield, aren't grabbing, check them and see if they're hard and stiff. Maybe time for some new tires. When I'm doing a restoration of this magnitude, I will send progress reports to my customer along the way, showing him every step. And when he saw this black car, he wanted either red or blue, because it looks like from our research online those were the two original colors for this car. So presto changeo, one red car with beige canopy. The red matches the pucks and the red elsewhere, as does the beige or tan color is the same that's on the cabinet down here. So that's the new paint scheme. Put some decals back on it. And there's only two rules of customer service. Rule number one, the customer's always right. Rule number two, when the customer's wrong, see rule number one.
The missile is erect, ready to spring to the sky.
There's lots of scratches in the plexiglass. Gonna try to take that out now. And here's the same area. They're just very, very fine. Most of it's gone. Genco decal in 10-cent denomination are touched up. There were no keys for these locks, but I knew we wanted to save them because this is a specially shaped cam and mounts onto that lock, so really wanted to save the original locks. So I found these keys that are correct, period, but not the right pattern. I opened the lock up and I took a couple of the pins out, and then I moved pins and also reshaped them. Basically changed the keying of the lock so that this key would fit. And you have two keys now, one for each side, plus a brand new lock on the front door. To lock the lid in place, when you bring the lid down, this protrusion or bracket is going to go down in position, and you have to press on this corner. You have to press in hard in order to get this lock to come up into place for the cam to fall into here. So if I turn the cam, it's hitting, but if I press on the back side of this, push it closed, then it goes all the way up and the key will easily come out. Now it's locked in place. So you have this side which comes upwards to lock in, and on the other side of the cabinet the cam comes down through the top, but it's the same thing. You need to push in on this to give it that clearance, and then it goes in real nice and easy. So likewise in reverse, to open the cabinet, you stick the key in, but before you attempt to turn it, before you turn that key, make sure that you're pressing in here, and then it'll just fall right out. Alright, here's your decal that shows you have to press in on the front glass in order to get this lock to fully work. And on this right hand side, the left hand side goes a lot easier, but this right hand side takes more force. And when I have this sitting in this position resting, the cam is waiting to fall in. You can see what happens when I push in on this. Okay, you do have to push it in with quite a bit of force, but notice the key dropped right in. That was the cam dropping into that bracket. So that's how you know it's fully locked, and you're good to go. To remove the playfield, you have 4 screws. 1, 2, 3, and 4, holding the playfield down. So those 4 screws come out, and then it'll lift up and out. When you have to get to the internals of this machine, you can prop open the lid, let it rest on the top. I put in extra screws along here. There were missing screw holes. I filled them up so you have good strong support. And then after you remove the 4 screws from the playfield, it will lift up, but you want to grab it here from the front corner, and you want to actually pull it out slightly as you lift this up. You lift to clear this and then pull it out slightly, and the playfield will drop down onto these metal rods that are sticking out. There's one on that side and there's one on that side. Okay, that metal rod, that allows you to be able to take the playfield and pull it out slightly, because you need to have it out away from the back as you tip it up. And then there's a prop rod on this side. But you want to be very careful in handling this, because there's no stop that'll prevent you from pulling this too far and having it drop right off of those rods. You'd come crashing down on all your electronics. That would not be a good thing. So just be very careful taking this playfield in and out. Then as you're putting the playfield back into position, after you lower it down, you can have it resting here, and what you want to do is put your finger underneath number 3. There's metal that goes along here, cardboard on top, which is fragile, but the metal underneath will support, and you can lift up to get back on the wooden ledge that's on there and back off of those metal strips. So you got to lift this up slightly as you push this in and let it drop down. This adjustment determines how many points it takes to get a free game. There are 3 pins. If you go all the way up to the very top 3 pins, then that will take 3,000 points, liberal. If you move the series down 1 set of pins like this, then that'll take 4,000. That takes 5,000 points to get a free game. So that's tight. And then if you move it all the way down here, this last position does not give you replays. So I'm going to set it on 4,000 points to get a free game. And to remind you of how many points it takes on each adjustment, I've stapled this little placard here, note there for you. And when you're going to get a free game, the red light on the front of the cabinet lights up. When I do a total restoration of a game, I'll try to put several dozen, if not 100 or 200 plays on the machine after it's done, to really make sure I've worked all the bugs out. And about every 10 or every dozen plays, I was having these 5 switches start to give me problems. And if you look inside, you can see that even though I cleaned the contact, after just a few plays, it's starting to get that black spot on it. and so that's arcing, and that causes a bad connection. The problem this was having, you know, we're looking at the underside of the playfield, but you have your 5 different slots you load, and you need to pay attention when you're playing this game. When you load the puck into slot number 1, you should get 100 points, and you hear a ding. When you load a puck into slot number 2, you will hear 2 dings in rapid succession, get 200 points, and you get 3, 4, and 500 when you get into those spots. And if you load pucks out of sequence, like let's say I load 2 and 3 first, then I come back and load 1, well, as soon as you complete the sequence, you'll get the points for all. So 1 plus 2 plus 3 plus 4 plus 5, you get them all loaded up, you should have gotten a total of 1,500 points, and you should have stepped this up 15 times until it's at its very end, which it is now. So if I let this go, okay, that's reset back to 0, and when you get 100 points, this pulls in once. That's puck number 1, and then 200 for puck number 2, 300, 400, and then 5. And as I get 500 points, you see this drop into that extra long tooth there. That's complete. And this wheel has to be stepped all the way up 15 times in order to tell the game that once you get over one of those playfield rollover switches, we can now eject all the pucks back out. So what I'm saying is, if you don't hear 1, 2, 3, 4, and 5 dings, if you don't get all those points, you are not going to eject the pucks out when you hit a rollover. So you want to watch for that to happen. And if it does happen, the thing to check is these contacts, see if they're starting to get dirty again. And so every one of these are the original ones, and what happens a lot of time in games like this is the contact itself is just swaged or press fit onto this leaf, and so you'll get a loose connection right between the contact and the leaf blade. So if you look, you will notice that I have soldered these in an attempt to remedy the loose connection, but that turned out not to be it. We're still getting this burning or arcing. And also, you know, when I clean these contacts, it takes the old plating off, or sometimes they're already arced, and so you have to take all that arcing off. So what I'm left with is raw metal, and that doesn't hold up quite as good as a brand new fresh contact. So what I've done is bought brand new switches, and if you look in there, you'll see that these are gold-plated contacts. So that's the best you can do for electrical connectivity. And then in addition, to keep the arcing down, what I did was I added a 0.1 microfarad capacitor across the contacts, and also there's positive voltage that comes in 20 volts, and it's connected through, it's a DC voltage, AC doesn't go through here. So because it's DC in one direction only, I also put a diode in and placed it in the proper polarity so that any back EMF that's generated that would want to cause arcing in these contacts as they open back up, any back EMF is going to be shunted through that diode, and then other voltage spikes will be collected by this capacitor. So between having all brand new contacts and then the capacitor and diode arrangement, I'm hoping that this is going to last for you for a long time, not give you any problems. But again, as you're playing the game, you want to make sure that you hear it give you the 1 bell and then 2, 3, 4, 5 bells, and you know when you got all 15, then you can eject them back out. Okay, and here's what I'm talking about. Proper operation looks like this: 100, 200, 2 quick bells, 300, that was 3 quick rings, 400, all right, and 5. Okay. The other way you'll know if it's not working properly is if you're getting dings, but then you put a puck in and you don't get any dings. If you don't get the 4 dings here, or any of them, or only get partial, then you have a problem with this contact. If you don't get any dings when you put it in, then you may have not gotten your 3 dings off of here, and so you may have a problem with this contact. But I did get all 15 dings, so now when I hit a rollover switch, I'm ready to go again. And to show you what happens when you load out of sequence, let's say I loaded 3 first. All right, pushed in, nothing. No 1 and 2. So I'll put 2 in, nothing. But, whoops, I hit that rollover. So as soon as I get 1 in here, you'll notice 6 dings in rapid succession. All right, and that brought me all the way up to here, and 600 points. So likewise, this, another rollover I hit. I get the 5, but nothing, because I need to get the 4 before it. So as soon as I get this in, I'll get 4 plus 5 all quickly. All right, and now it's ready to eject. The other reason I decided to reproduce these tires, and really the main reason I went through all the work to do it, was I spent hours online and called different toy manufacturers and model makers. Nobody makes this exact diameter of tire, and you need a very specific size because this plate under here, it's just barely riding above the playfield, and it activates the playfield switches. And so if you go with a bigger diameter tire, you could lower this, but then the bigger diameter would rub as you turn. I'd get into grinding out more of this body. And you cannot go with a smaller diameter tire because you'd have to raise this plate. And if you look in there, you see there's drive gears for the tires, and you will hit those drive gears. So unless you re-gear everything, you're not going to go smaller. And so all that being considered, and with the shape of the original tires, decided it was time to reproduce them.
All right, let's give them a solid punch.
For more information, visit GameRoomRepair.com.